3 minutos.
Good morning, everybody. Welcome to the third day of our calorimetry conference. We are starting just a minute ahead of time to give people the chance to move to the respective room. So if you are interested in biocalorimetry, please stay here. But if you are more interested in flow calorimetry and process safety, you should move to the main meeting. In any case, I wish you an interesting conference, lectures, stimulating discussions, and a good time. So please enjoy the meeting, and Heike, go ahead.
Thank you very much, Stefan, for the introduction. Good morning, everybody. I would like to welcome to this morning session on biocalorimetry. My name is Heike Bunjes from the University of Braunschweig, and I would like to guide you through this session. The first speaker is already on the screen, I noticed. I think we'll have to give you the moderator rights. I try to do this.
Okay, thank you.
But it doesn't work, I guess. Now I will have to do this like this. Now it's there. Now it's not there already. I tried to do.
Still not. Okay, now I have the right to share.
So, so maybe you can try to share your screen, and I would like to introduce your talk, which will take us to Colombia. We will learn about the use of isothermal calorimetry to measure cadmium-related microbial activity and antagonic activity of fungal populations of cacao growing farms in Colombia. Please go ahead. We're looking forward to your talk.
Thank you very much, Ms. Bunjes. Thank you to all organizers to let me speak a little bit about our experience regarding experiments with isothermal microcalorimetry here in Colombia. My name is Daniel Bravo. I am PhD researcher at the Colombian Corporation of research center for agricultural purposes. I will present the uses of isothermal microchrometry to measure cadmium-related microbial activity of some populations from soil samples of cacao growing farms here in Colombia. And I will present another case regarding the antagonistic activity of fungal populations also in cacao growing farms here. So we have two posters. I invite to all of you during the coffee breaks to please go to the poster from Liz Uribe and Claudia Jaramillo to get more in contact with the details of this research. Presenting an outlook, I will show three main topics. The first one is the contextualization of the issue of cadmium and also the diseases in the cacao crop in Colombia, and the calorimetric uses. The first case, as I said, with the functional group of cadmium-tolerant bacteria and regarding the metabolic activity of this functional group. And the second case will be the assessing of antifungal activity of two species of Trichoderma asperellum against a cacao pathogen which is called Scopulariopsis sp. So there is some issues in cacao production. Cacao is the largest crop production in Central and South America, but there are certain concerns regarding, for instance, the problematic of cadmium content. The cadmium in both soils and cocoa beans are problematic since there is a new regulation that started from 1st January 2019. This is a regulation from Codex Alimentarius and the European Union, but it's a regulation on the chocolates, the maximal permissible content on chocolates. However, as you know, cocoa beans are the raw material by which chocolates are done. So that is the difficult, and the other thing is the cacao plants has been classified as hyperaccumulator of cadmium, mainly between other heavy metals. So that is a big concern here in Colombia. And another one is the diseases caused by specific fungus, opportunistic fungus specifically. Interestingly, there is some ways to control specifically with other good regulators or biological regulators such as Trichoderma and Bacillus. Looking at the data, we have performed a national survey of cadmium in soils of cacao growing farms in Colombia, and we published just last month this national survey. And we have seen also that in cocoa beans, more than 52% of the assessed farms are in the boundary between the 0.8 milligram per kilogram of cadmium, which is the maximal permissible level for chocolate, and the rest is more or less okay below 0.8 milligram per kilogram. So indeed is an issue here, the concentration and the content within the cacao plantations. But why using bioremediation? This is because the cadmium-tolerant bacteria has the capability to transform the cadmium from soluble forms into non-soluble forms. That is called bioweathering. And by bioweathering, the idea is to use the soluble fraction of cadmium present in soil in forms such as cadmium chloride or cadmium chloride, and less frequently like cadmium ions, into this mineral induced biologically by this cadmium-tolerant bacteria in forms of otavite, greenockite, howleyite, which are secondary forms and geostable forms of cadmium. In these forms, cadmium is not available in the root system and therefore will not be translocated in the cocoa beans. So we were performing several experimental designs, including geophysics approaches also, using the geoelectrical assessments with the electrical resistivity tomography in 2 dimensions, and looking in a non-destructive way the hotspots of cadmium at the subsoil surface level. Once we get the hotspots, we perform the trial pits, and we took some samples, performing some homogenization of the samples. Then we took 1 gram of the homogenized mixed composite sample, and using a liquid medium, which is a Mergate medium specialized for cadmium assessments, we have performed the heat flow thermograms, performing an integration of the heat flow data to get the heat, and then biological meaning information regarding the soil samples. So here you can see a thermogram of a soil sample rich in cadmium. The gray curve corresponds to a normal, let's say, a natural content of cadmium within the sample, and the black curve corresponds at the same sample but amended with 4 milligram per kilogram of cadmium chloride. And interesting, you can see here that there is a first peak in the gray curve, which corresponds to the fast-growing bacterial populations of cadmium-tolerant bacteria of this functional group. But when we add 4 milligram per kilogram of cadmium, we can observe this second peak, which corresponds to more lower populations, which are called slow-growing bacteria, and there is an interesting fraction of the populations within the bacterial community in these soil samples. So microcalorimetry allows us, with a little bit of pressure, with more concentration of cadmium within the sample, to express this metabolic activity of other populations that otherwise will be not possible to measure. Also, we have seen interesting differences between soil samples with high cadmium concentrations, like this black curve, with medium cadmium concentration, like this curve here in red, and with lower cadmium concentration, like the green curve here. We also performed some amendments with 1 milligram per kilogram of cadmium, and we have seen also again this activity related to slow-growing populations as part of the whole community within the soil sample. Then when we observe and compare less complex soil samples with just one peak of activity, we have also seen these differences between a high cadmium concentration, medium, and lower cadmium concentration. And when we perform the fitting of the raw data, we get these synetical growth parameters, such as the growth rate of the whole community. And we have seen, comparing the maximal heat produced, that some samples produce a large scale of maximal heat with more or less interesting growth rate. However, there are some samples with a low Qmax, low maximum heat produced, but with a little bit more of growth rate. Let's say there is a little bit more biomass production at this point of these samples. And looking to another synetical parameters, such as the lambda, which is the adaptation phase, we can observe that also there is an interesting behavior between the soil samples with natural cadmium content that requires more than 10 hours to be adapted to the medium, and then going on with the cadmium tolerance. But when we add 1 milligram per kilogram of cadmium, we have seen that the same samples have a better response in terms of adaptation phase. They are below 10 hours, and this is important in terms of selecting specific bacterial populations that are capable to be adapted in very fast way and could be prospected for a bioproduct release or formulation. And we have also observed an interesting correlation between the maximal heat produced against the heat flow of the measurements in both in natural cadmium content assessments or in the amendment assessed. So interestingly, we have seen in the amendment a little bit of better distribution of the samples within the ratios of Qmax and heat flow. So that's for the first case. For the second case, as I told you before, we were seeking the activity of antagonism between those microorganisms which are part of our national germplasm bank for agricultural purposes. And we have seen this Trichoderma spirillum species interesting to use it for biological control of this fungus, which is called Scopulariopsis sp. This little one is responsible of almost 4% of the losses in the crop production in Ecuador, Venezuela, Brazil, and Colombia. So that's why it's really important to measure the antifungal activity once we want to tackle this issue with biocontrol. And we have performed several experiments in the 20 milliliters ampoules of the tamer. We have a tamer here in Colombia. So we get this solid medium. We have also performed liquids medium with the admix ampoule system to increase the activity to be assessed. And we have seen interesting things. Here in the first thermogram, you can see the behavior of the heat flow to the individual strains. So this yellow and the blue heat flows corresponds to the Trichoderma spirillum species. Interestingly, this blue corresponds to one Trichoderma spirillum isolated from strawberry, and the yellow one corresponds to one Trichoderma spirillum isolated from the cocoa pods. The pods are the fruits of cacao. And you can see also here, in the green curve, the Bacillus ameligoricofasciens activity compared to the Trichoderma and the Scopulariopsis, the pathogen here. So after 24 hours, you can see that there is an interesting increase in heat flow of the Trichoderma species, whereas the Scopulariopsis is a slow-growing microorganism. So after 72 hours, you can see there is an increase in the heat flow and the metabolic activity. In this other experiment, since we have characterized the times they need to be really active, we have after 24 hours of growing the Scopulariopsis sp, the other strains, the biocontrollers, and we have seen that TH406, the Trichoderma spirillum isolate from pod, are really interesting and have an interesting fluxes of heat flow against the pathogen. And we took subsamples of the ampoules here during this experiment, and we visualized that precisely, and we saw the destruction of the Scopulariopsis due to the Trichoderma spirillum. Here, for instance, you can see internal hyphae of TH406 inside of the pathogen. So there is a mycoparasitism in this way. And we have combined also the Fick index, and we get this score of 4.88, which corresponds to antagonism. So in that way, what's next? We want to use both cadmium-tolerant bacteria and the biocontrollers to perform bioproducts, to scale the production, and at each stage of the evaluations, we have the idea to use the calorimetry like the core of our research to get improving cocoa crops in our country with less cadmium available and with less diseases. So I'm arriving to the end of my presentation. I would like to thank the Colombian Ministry for Agricultural and Rural Development, AgroSavia, with the internal funding, and of course our network of scientists and partners, especially Dr. Olivier Bressan, who all the time has give us a lot of improvement and advices in microcalorimetry, but also the internal colleagues from the Cacao Network in Colombia. And thank you very much to listen to my presentation.
Thank you very much for sharing this interesting information. What questions? Who are the question? There's already Thomas Masko has a question. Please go ahead. I'll have a look at the chat as well.
Okay. Many thanks, Daniel, for this very nice presentation. I have a lot of questions, and of course, there's not enough time to answer all of them. Maybe I focus on the most two urgent ones. One is from the practical point of view. If you recognize that your bacteria are fixing this cadmium, can you do anything from the practical point of view? And the second question is from the instrumental point of view. I have seen several sudden peaks, somehow 7 hours, 30 hours, and 50 hours in the case 1. And it's something which I seldom see in my experiments. So maybe you can give some explanation for these surprising, at least in my eyes, surprising results. So,
okay. Thank you, Thomas, for your questions. The first one, in the practical point of view, we are developing nowadays a bioproduct using a selected group of cadmium-tolerant bacteria from 3 districts, the cacao producing districts in Colombia. We performed several experiments not only with isothermal microcalorimetry but also with ICP-OES to measure the residual cadmium in the batch experiments with this cadmium-tolerant bacteria to analyze the rates of immobilization that these bacteria have. So we combine the ICP with the IMC, and then we select these microorganisms. So we are in the phase of pre-formulation, and the idea is also to use isothermal microcalorimetry to see how the excipients could affect the activity in terms of immobilization of cadmium. So that's in the practical point of view. In the methodological point of view, I believe we have to also try to go longer in our experiments, because of course the activity we measure is just in a few hours or in a few days, but once the bacteria are delivered in field, they will be, let's say, at least 3 months during that time, and then we need to reintroduce the populations. So we have to be that during the 3 months or the months that we will release the bacteria, they are really active, and that's the idea, incorporating new experiments during the bioformulation. Yeah, I don't know if I answer all your questions.
The last question was about these sudden peaks. You know, if you observe grow, things happens maybe in the region of hours, seldom in the region of minutes.
Okay, but this is because I was showing only the thermograms for soil samples. We did not in the first part finish the bioprospection. So this is one part of the work of my PhD student. So she was trying to see how works the populations directly from the soil samples. So the idea is that we took also subsamples during the experiment of calorimetry of those peaks you saw, and do metagenomics to put the name and surname of the bacteria that are responsible of the peaks. But that is working on. So yeah, we did not have the results. Mm-hmm.
Okay, thank you very much.
Thank you, Thomas.
Are there further questions? They should preferably be put in the chat, because then it's easier to see them. Because I cannot have a look at all people in the audience. But this does not seem to be the case. Thank you very much again for the presentation, for the discussion as well, of course. Maybe you can stop sharing your screen so that I can give the presenter role to someone else. Thank you a lot. So the next talk will be given by you.